I just shared my screen. Is it visible?
Yeah, yes, will.
Okay, right. Today we'll get started with Terraform. Okay, since we learned AWS last 2 weeks, I think right now everybody are good at right understanding AWS resources, like how to provision infrastructure in AWS using console. Predominantly, we work using console, and we also know how to provision resources using CLI as well. But let us take those learnings and then expand our skills in terms of Terraform. Like with respect, like Terraform is like infrastructure as a code tool. Like what this Terraform does, we actually write code. With the help of code, we can provision whatever servers we wanted to provision, like whatever infra we wanted to provision, be it your AWS S3 bucket or EC2 instance or any RDS or any CloudWatch alarms and all. Like so far, right? If you go to AWS, right, any services, right, we usually log into console and then provision any services based on what we want. But from today, we will learn this tool, Terraform tool. With this particular tool, we write like kind of code. Okay, like if you wanted to provision EC2 server, so we write some code. So that particular code will help us like provisioning like the required services. Okay, but before discussing about this Terraform, let us try to understand some problem statements and why do we need Terraform. Okay, and how are we managing the infra before Terraform, and what challenges we had, and how this Terraform is helping us to solve those problem statements. Okay, so right, if you look at the problem statement here, like historically managing IT infrastructure was a manual process. Okay, so what it means, like when we didn't have this cloud exist, as I keep telling, like we used to have data centers where like the companies used to buy servers and then install and then configuring it on a data centers. Okay, which involves like a lot of stuff actually, like buying servers, installing all those things. It actually takes some time. Okay, we cannot just spin up like servers as and when we want. Okay, we had to like, let's say if you wanted to deploy an applications, so for deploying any applications we need like computing power. Okay, when I say computing power, we need the server capacity and all. So what companies used to do in order to deploy their applications, right, before even deploying, like before even building the applications, or they usually buy all the servers, like whatever servers they needed to, they buy servers and then like kind of install in a data center. So that is where, right, they would be needing it all, like the networking team, and then server admin team who can install the servers, and then networking team, storage team. Like it is like a tedious process. Okay, all those things. Typically, right, it actually takes some 2 to 3 months or maybe more than that also, like buying the servers, installing all those things. Literally, right, companies used to wait at least 3 to 6 months just for installing the servers and then configuring the servers. Okay, and then deploying the applications. And later comes like kind of clouds, okay, like AWS or GCP or any other clouds. So with the help of these clouds, what we used to do, like, okay, we just have to have an account in these clouds, and then, right, like the similar way like what we did last 2 weeks, we just have to have an account created in cloud environments, and then provision the servers, right? Like with this process, what, right, here we are not buying any servers. Okay, and we are also least bothered about how did these servers install all those things. Okay, so what we want is like we wanted to have a server which we can provision using this way. Okay, and this can be done less than 5 minutes. But this is not the case if we wanted to spin up servers, on premises servers, like on premises data centers. Okay, which usually takes longer time because everything has to be done physically. Okay, and what are the challenges actually, right, like going into these on-premises data centers, and also what are the challenges when we are going with like provisioning these servers. Like, see, we should know the problem statements, then we will think it out actually how to resolve those problem statements. Okay, how we can better provision these servers and all effectively. Like in earlier days, right? If at all we wanted to provision 100 servers, okay, be it in on-premises data center or maybe cloud. Okay, so what people used to do, yeah, the first thing is like they do many steps, like they do it manually. Okay, if they do it manually, and if they wanted to provision 100 servers, and there is no guarantee that okay all 100 servers will be of same configurations, because right, just think of it, okay, each server is having around 100 steps, like 100 steps to build one complete server. Okay, that means we have to write like kind of we had to apply, or we had to create 100 steps across every server. Okay, and right, it is like a tedious job, and right, we may end up right doing some wrong configurations. That means the servers will not be in sync. Okay, when I say sync, like we cannot build all 100 servers with same configurations, because to build each server we rely on the manual steps. Okay, and right, and and also right, as we know that okay, building manual things makes some kind of mistakes, and people usually write some kind of scripts, shell scripts, to do some kind of automation stuff. Okay, and again this with to the certain extent, scripts are helpful for doing some kind of automation tasks, uh, like for any of the servers. But what are the problem statements even with the scripts? Okay, the scripts are not consistent. Okay, so right, one person may write some scripts, okay, which may work on one flavor of OS and might not work the same script on other flavor of, like another flavor of server. Be it like if the administrator is written a script which will work only on CentOS, so it cannot work on Ubuntu. Yeah, but right, again, it is up to the administrator how you can write the scripting and all. He can also have one script which will work across different environments, but again they are not consistent. Like it is like, I mean, for building small based kind of automation, scripts are okay. But if somebody wanted to build the kind of complex applications, like complex automation stuff, scripts are not the go-to solution. And then not idempotent. So when I say not idempotent, if we run the script 100 times, okay, let's say right, the very first time we might have run a script, okay, it gives us some result. And if we continue to run the same script, maybe right 100 different times, and there is no guarantee that okay, it gives us the same result. Okay, that we call it as not idempotent, and we may get some compatibility issues, right? The scripts are may not be support, like the script which is written for one particular OS might not support an other OS. Like we may get some kind of compatibility issues, and error prone and then tedious, right? For building any complex based automations, the scripts are like kind of tedious. Yeah. For building any kind of small automations, the scripts are good, but yeah, the scripts are not to the certain extent, scripts are good, but not the building of any complex based applications. And with the help of scripts, like we can achieve the kind of minimal features, and more efforts are needed if at all we wanted to build any complex automation solutions. Okay, so considering all these things, right? So one thing is like the managing infra was a manual process earlier, and there were a lot of challenges if at all we wanted to build many servers. And how can we automate it? Okay, people used to rely on scripting to do certain kind of automations, but even the scripts brings us a lot of challenges, and these are the challenges which I wanted to talk here, right? And what is the next solution like? So that is where we can use these kind of IAC tools, predominantly Terraform. Okay, so like IAC tools, nothing but infrastructure as a code. So what we do with these tools, we write code for one server. The same code can be used, right, for building many other servers. So that means if we have written a correct code for one server, since you are going to use the same code for n number of servers, okay, as long as your code is correct, that means you can build 100 different servers with same configurations. Okay, because here you are not doing it any automation as such. Here you are not doing any manual approach as such. okay, you are relying on the some kind of standard syntax. Okay, when we are writing this Terraform code, so we rely on some kind of syntaxes. Okay, so with some syntax, we write the Terraform code, which will help us build the servers with same configurations, no matter whether you build 10 servers or 100 different servers. Any questions so far? Is it clear? The problem statements, the challenges, and okay, I will talk about like how this Terraform will solve all these problem statements. Is it clear, everyone?
Yes, it is.
Yes, man. Yeah.
Yes, yes.
Okay.
So
Now,
what is the difference between this Terraform and Ansible?
okay, Terraform and Ansible both are different actually. So when I say Terraform, so mainly we use Terraform for infra provisioning it. Okay, when I say infra provisioning, your servers provisioning, okay, be it your AWS EC2, S3 or any other infrastructure provisioning. Okay, like normally what we do, we first build the servers. After we build the servers, we might do some kind of configuration changes, like creation of users, or maybe creation of some files, configurations, installing your applications. Because having just your like brand new operating system server, you cannot use it unless you make some kind of like, unless you deploy some applications on it. Okay, let's say WebLogic. Okay, it's a middleware platform. Unless you install this any kind of softwares on it, like be it your web server or be it your middleware like WebLogic or WebSphere servers, unless you install those servers, the servers cannot, I mean, you cannot use that application, whatever you deploy into that servers. So we use Terraform to provision those servers. Okay, it is like bringing those servers, like installing those servers and all. After you configure these servers, so we use Ansible to configure those configuration changes, like installing any softwares, creation of users, files, all those things. Okay.
Okay. Thank you.
So what is this Terraform like? Okay, it is an open source tool and created by HashiCorp, right? So it allows us to codify your infrastructure, like, so that means we write code with the help of this Terraform, and that code will help us to provision the required infrastructure. Okay, and we write kind of declarative configuration files, and the good thing here is that when we are provisioning the servers using manual approaches, because as we go in about 1 year, we might be making n number of changes to your servers, and it is difficult to track like who did what changes and all over the period of 1 year. If you have provisioned a server using manually, and every time you to do any kind of stuff, you rely on the manual stuff, and because there is no track actually, it is difficult to track if somebody is making some changes to your servers manually. But here good thing is that since we are writing the code here for your infrastructure provisioning, every time when somebody makes the code changes, because whatever code you write here, the Terraform code, eventually we will be storing it in a GitHub. Okay, like any version control systems. So in this case, we write Terraform code and then we will keep it in a GitHub. So if somebody makes any changes, let's say today I have written a Terraform code to build an EC2 server, and this particular code I will be storing it in a GitHub, and tomorrow I make some more changes which will build S3 bucket as well. So that means going forward, since I'm going to make all the changes at the code level, and this particular code will be storing it in a GitHub. So I mean, anybody being in the project, they can easily track like, okay, like what did I make these changes, when did I make all those changes. Okay, that is good part here with respect to Terraform. And Terraform is platform agnostic. When I say platform agnostic, with Terraform you can build infrastructure on any of the cloud providers. Not only cloud providers, you can also write Terraform code for provisioning your on-premises servers as well. So that means normally AWS provides cloud formation as the right here. AWS provides cloud formation as the service. With this service, right, we can have some kind of templates again, cloud formation templates. Okay, with the help of cloud formation templates, we can again automate the the building of any services, be it your EC2, S3, all those things. Okay, we write cloud formation templates, and again, these cloud formation templates can be version control, all those things. But if you learn these cloud formation templates, you can automate only your AWS part. That means you can only provision your AWS services. Similarly, like any other cloud, like Azure. Okay, if you are taking Azure as the cloud, similarly, like how this cloud formation service in AWS, right, does this automation. Azure provides ARM template, ARM templates. Again, right, right. Let's say in an organization, we will have multiple clouds, and to do right, many of the people nowadays are going for automation. Like if we have multiple providers or multiple clouds are being used in our organization, so for every cloud you have to learn some kind of service which can automate your infra. But learning this Terraform, you just learn Terraform which can automate, right, on any of the cloud solutions. Okay, that is what this Terraform is, a platform agnostic. Okay, with Terraform we can build infrastructure on any of these cloud providers, be it your AWS, be it your Azure or Google and all. And Terraform configuration code is written in .tf files. Okay, so the extension must be .tf files while we are writing Terraform code. Okay, as we learn, right, this whole week I'm planning to spend on Terraform itself. Okay, I will teach you everything, like end to end, each and every line, so that, right, I'll give you very strong foundation, so that, right, you can take this strong foundation and then you can expand these skills for building any of the other services also. As I said, Terraform is open source project. Okay, and you can just simply download Terraform binary and then can use it. Okay, and right.
Yeah, can it be used to build our Docker and Kubernetes infra as well?
Yes.
Oh, okay. Thank you.
But generally, right, I will show you, right, in some time today itself, like how many providers will this Terraform supports. So everything we call it as providers. So AWS is one provider which can support by this Terraform. So Azure is one provider. So like how many number of providers supported by this Terraform, all those things I will be showing it to you and in today's class itself, so that you'll get to know all those things.
Thank you.
And right, as I said, it is not only open source project. It can also support like enterprise plans as well. Like HashiCorp is the one which is being supported by this Terraform. And HashiCorp provides support plans like Terraform Cloud and Terraform Enterprise. Okay, there is a like, because like just think of it, okay, your organization is kind of bank. Okay, and usually banks don't rely on any open source projects, like open source solution. They usually don't prefer any open source solutions. So they wanted to have some kind of support from the respective service. Okay, if they wanted to leverage this Terraform, they obviously talk to this HashiCorp and then they tell them their requirement, like, okay, they wanted to build this Terraform solution for building infrastructure. So they obviously go with enterprise solutions. Okay, when I say enterprise solutions, like they always need some kind of support from the kind of vendor. Okay, these we will call it as vendors. Okay, so for Terraform, HashiCorp is the vendor. So what these companies does, like they don't wanted to build their solutions using this open source project. So they usually buy some services from HashiCorp to have enterprise solutions. But the working wise, the code wise, like everything remains same, whether you are working on open source project or you are working on enterprise solution or you are working on cloud, Terraform cloud, you'll be writing code in same way. Okay, but the only thing is, like, if you are getting some kind of issues, right, if you are working on open source projects, then you have to rely on the community support. So that means you have to rely on some Google, like any like you have to find the solutions on your own. But if you are having kind of enterprise support for that particular tool, you can always raise a ticket to your HashiCorp where they can help you out. Okay, in case if you come across any issues and all while you are working on Terraform. Okay, this Terraform enterprise again, like they will give you binary, and this has to be installed on your servers. And right, Terraform Cloud is another offering by HashiCorp. So here, right, if we are managing this Terraform Cloud, like if you wanted to leverage this Terraform Cloud, you don't have to install Terraform on your on-premises servers, like be it on your on-premises servers or your AWS servers. This will be installed in Terraform, like HashiCorp servers itself. You will just like, you will use this. This is kind of like PaaS service. Okay, you will use this service. Okay, you don't have to worry about that underlying underlying infrastructure, all those things. Okay, it is just like similar to our Gmail. We will just create an account in Terraform Cloud and then can use it. Okay, so infrastructure is defined in code, and then good thing is like Terraform has a very good documentation. We can just see, when we understand Terraform documentation, we will be like, you are already experts in Terraform. That is what I can say. I will help you, right, very clearly, like how do we read the documentation, because we may need to write up some 100 different lines, okay, for provisioning some services, and we cannot just remember all 100 lines of code or maybe 200 lines of code, right? Every code we will just, right, if you go to Terraform documentation, terraform.io is the Terraform right, official website. So I will show you, like, right from here, and I will just navigate, and then I will like I will tell like how do we grab the code so that that particular code will be used for provisioning like what services and all. And right, and what are the benefits of using this IAC? So as I said, like increase speed and efficiency, right? Just think of it, okay, in AWS, and as on today, like if you wanted to build one server, just think of it, okay, it is taking 5 minutes time. If you wanted to build 100 different servers, so we have to multiply 100 into 5. It may be some 500 minutes. Because here we are not making any automation. Okay, the same way, if we wanted to build 100 servers using right, using Terraform, we write code for one server and then run it. Okay, and then the same code can be used across for different server, for different 100 servers. So it's just matter of minutes, right? You can build all 100 servers, and good thing is that all 100 servers will be coming in consistency in terms of configuration and all. Okay, so like the benefits what we get using these IAC tools are increased speed and efficiency, and then more reusability. Okay, so let's say, right, we write Terraform templates, and the same templates can be reused across different regions. So here, right, different regions will be there. And if you provision server here, and if at all I wanted to have same server in any other region, again I had to follow same steps what I followed here for building these services. Okay, and as I said, like again, we rely on these manual steps. We may make some kind of mistakes here, and which is not the case when we use this Terraform and reduced cost. Okay, so this Terraform will help us building servers very fast. That means like with just one Terraform expert, he can write Terraform code, can build n number of servers, and it is like the manpower. Just think of it here, to build 100 different servers, we may need more manpower, like we need more resources in order to build 100 servers. Like one person just building 100 servers takes months, okay, to do everything. Here, right, if we have Terraform expert, and he can just write code for no matter whether it is 100 servers or 1,000 servers, he can just simply write code, and then he can spin up any other servers, okay, any number of servers. Okay, so that means companies will reduce a lot of manpower. So as they reduce manpower, they will be reducing the cost as well. and everything is codified. Because for provisioning any infrastructure, we write code, and this code is version control, because it's not like, okay, we write code and we will keep it in our laptops, because we wanted to track this version control, or like we wanted to track like how many changes are going to happen on this particular code. Hence, we are going to store this code in a version control. And if we are storing in version control, it is like better collaboration. So what it means, like, let's say if I have a project, like if my organization has received some Terraform project where the requirement is like maybe provisioning 10 EC2 servers and 10 S3 buckets and 10 RDS servers. And ideally, this particular project will be given to any one particular team. So when I say again a team, so we will have multiple peoples working within that particular team. So that means like as a project manager or Scrum manager, he will be raising some kind of Jira tickets, and then assigning like individual tools, like maybe he can have one Jira ticket assigned to one particular person, where he is responsible for building 10 EC2 servers. The other person is responsible for building S3 buckets the same way. So that means having this code stored in a version control, like people will come to know like who are building what code and all those things. Like it is better collaboration. It is actually kind of Git feature. It is not Terraform feature, but we can leverage multiple tools and then build the solutions in a better way and less human error. Because here for everything we rely on the Terraform documentation. We cannot write code on our own. We have to follow some kind of syntax guidelines. And when we are following these syntax guidelines, it is like the less chances of we making some errors and better disaster recovery. So let's rate if at all we wanted to build similar environment in a DR site, so disaster recovery site. Having this Terraform code is in place, I can just run few commands which can bring up your complete DR site, okay, in just matter of minutes. Okay, so as we use all these benefits, obviously customer gets a lot of benefit. Okay, these are all about the benefits of this IAC. Okay, let us try to understand Terraform architecture. Okay, Terraform is very simple installation. You just have to download a binary. That's all. Okay, that binary, you don't have to install that binary as also. Okay, I will show you how to download binary. Okay, you just go here, Terraform download. Okay, it will take you this page. Okay, here the left side, if you see like different types of operating systems, based on what type of operating system you are using, the respective binaries can be downloaded. Let's say if I take an example of Windows, right here, Windows. So based on your architecture type, you just have to download this package. That means when I click on this link, the Terraform binary will get downloaded here. If you look at here, the Terraform version, it is being downloaded as 1.9.0. Okay, so that means your Terraform binary will get downloaded onto your downloads. Okay, you can just simply extract. Okay, let me extract it. Okay, and this is the binary. Okay, and if I take command prompt here, so see, currently my this installer Terraform binary, okay, it is in downloads inside this folder. I can take command prompt here, cmd. So if I run cmd, like command prompt will open on whichever the location you are. So I wanted to open a command prompt being on this particular folder or the location. Hence you can see, when I run this pwd won't work here. You can see, you are in C drive users downloads. Within this downloads, this is the folder. Since my binary is here, okay, so this is ls command does not work in command prompt. Ls command will work only in git bash. Okay, so since this command prompt, right, is
DAR works in
yeah,
Windows.
I know. Yeah, that's what I am trying to say. In Windows, you have to run this dir command, so that right, it will just give you what are the files and folders exist here. So when you run this dir command, it will list you like, okay, like what are the files and folders here. When you run this terraform-v, see, right, terraform-v, it is giving you the version. So that means you are already installed Terraform. But if you follow this approach, every time you have to be inside this a location where your Terraform binaries exist. So for that, what we do, we will set the environmental path for this, right? For this Terraform binary. So what we do, let me just close it, this one, because I don't want it to come every time to this particular location and then run Terraform commands. Because if I don't set this environmental path for this particular binary, it cannot run from any other location. If I go and run from any other location, in this case, right, if you look at here, users Venoji, if I run here terraform-v, okay, it won't work ideally, but let me run this one. So if you look at here, terraform-v, it is giving me the Terraform version, Terraform 1.8.3. Because this particular Terraform binary, I installed maybe 2 months ago. Okay. When I installed Terraform on my Windows laptop 2 months ago, this was the version 1.8.3. Now, as we downloaded the latest version, which is again 1.9.0, it says your version of Terraform is out of date. I mean, that means this is out of date. The latest version is 1.9.0. You can download and then, right, set the path. So in this case, where is, you can run this command. Okay, you can run this where is Terraform command. Okay, right. This particular binary, I have initially when I downloaded the binary will get downloaded onto your downloads folder. So ideally, we don't keep any of the softwares in downloads folder. Just think of it, a downloads folder is a temporary location where everything will get downloaded. And once in a while, right, probably we may also clean up this downloads folder. So it is not a good practice. We keeping any softwares under this downloads folder. So what you have to do, right, you copy this software from here. Generally, we keep all the softwares in C drive. Okay, and right, go to C drive, go to your users, and go to your user home directory. This is where you can create a directory. And again, it is not necessary that, okay, you need to create the folder here, but it is a good practice keeping your softwares in a C drive. Ideally, we don't remove any softwares, like any of the folders and enough files and folders from C drive. So here, right, I just created a Terraform folder. Okay, inside this folder, I can just copy paste that, like whatever binary we downloaded as part of this. If I expand this folder, so this is the binary. So what we have to do, just copy this binary, go to your C drive users, your user home directory, create a directory called Terraform. At least, right, with having this Terraform, at least you'll get to know, okay, this is a Terraform binary. Just create a folder with Terraform and inside this Terraform folder, you create this, like you copy this binary, like whatever you downloaded. So in this case, if you look at here, right, the earlier one, the Terraform, which I installed 21 May. Okay, it's almost 1.5 month back. And right, so like this is the binary I placed inside this user's home directory and Terraform directory. And right, again, if I just run here, right, if I take command prompt here, if I run Terraform, it will give me the Terraform version, which is in this particular place. So if I wanted to work across everywhere, like I took earlier one more command prompt, which is right by default we are into our users home directory. Even if I run Terraform-v, it will give me the version which is installed in this particular place. Okay, like in this particular place, users Venusi and Terraform. So that means currently my PC has two different versions of Terraform binaries. Okay, so one is a 1.3. I also have a Terraform binary which is downloaded onto my downloads folder, which is giving me the Terraform version 1.9. But ideally, right, I don't want two different versions of Terraform. So what we have to do, I will take this latest binary. I will take this is the latest binary. I will replace that users Terraform. So okay, it did not copy. Let me copy. So this is the latest binary which I downloaded. I copy this one. Okay, replace the file. So that means you can see the date modified. So this is the latest binary which we downloaded, and then that particular the binary. Just think of it. In your case, it is not already exist. So what you have to do, you just simply have to create Terraform folder, and then keep that Terraform binary here. And after that, you need to set the environmental path. Okay. So go to here, right? You'll have this edit the system environmental variables, or you can go to your this PC, right click, properties, advanced system settings, environmental variables, your path, edit this path. So right, this is where right what you have to do. You go to you need to take the path of this Terraform binary. Okay, like this. Just put your cursor here. So it will give you the path of this particular location. In this case, C drive, users Venusi and Terraform. Copy this path. Go to your environmental variables. So this is where, right, in this case, right, like this. So what you do in your case, just click here, new, just paste that. That's all. Okay, since it is already present in my case, so I don't want it to add. But in your case, copy this location where you have put your Terraform binary, and then set the path to this particular binary. Okay, and this is how you need to set the path. So I will just cancel it. In your case, just click new and then put your binary location and then OK, and then come out and then next OK. So that means, so this is how you need to download your Terraform binary and set the environmental path. So once you set the environmental path, okay, you take the new command prompt. Okay, you take the new command prompt, and when you run Terraform-v, now can you see, like from now on, in whichever location I'm present, it will give me the Terraform binary location which is present in this particular path. Is it clear? This is
Yes.
very simple binary. Okay, you just have to download this binary, set the path. That's all. Terraform is already installed on your PC. Anybody has any doubt?
No.
Okay.
Yeah, but when you compare to other tools, what is the additional benefit of Terraform?
Now, when you say what is the other tools, means what tool you wanted to
Because
compare?
similar kind of Terraform tools which will does, there are other things in the market, right? What is the why do we have to go for with Terraform only?
Okay, and do you know any Terraform, any other competitors to Terraform? I mean, I'm just
No.
casually checking. Okay, so as I said right earlier, right, we have to understand the importance of like any tool what we are going to learn. So in this case, we are going to learn Terraform. So what this Terraform does, like infra automation tool. Okay, as I said earlier, AWS provides like inbuilt service. Again, in this case, cloud formation. This is again infra automation tool, infra automation service, which you can do infra automation only on your AWS platform. Okay, similarly, as I said, Azure. Like again, Azure has some different services like ARM templates. With ARM templates, you can only do infra provision on your AWS services. But if you learn this Terraform, with Terraform, you can provision or you can automate right in your infra on any of these cloud providers. So that is where Terraform has a good demand. And recently, we have something called Pulumi, which is almost right considerably very latest. Probably right. See, Terraform will not be replaced anytime in next 5 years. Probably, if you ask me, there is a tool which can take over this Terraform role, and this is the tool, but it is not going to happen in next 5 years at least. Pulumi is another, right? If you can look here, infrastructure as a code in any programming language. Okay, but as of now, this like Terraform relies on some it actually comes up its own languages. Okay, HashiCorp configuration language. But this Pulumi, right, is another infrastructure as a code. Okay, probably this can replace maybe after 5 years or maybe 7 years down the line. I'm not sure actually when it is going to replace, but it may replace. But right, it will bring us some more benefits what currently Terraform is offering. Correct, right? If some other offering wanted to replace the existing resource, I mean existing things, obviously this has to provide the more benefit, okay, in terms of cost or efficiency to the companies. Then only people will move from Terraform to any other tool. But as of now, this is very uh, latest tool. Usually people, I think, very, I mean, right? See, this has to be proven in the industries first, right? People do some POCs, and only if they are get convinced. Again, right, majority of the people are already using Terraform for infrastructure provisioning. But again, to migrate all the servers from Terraform to these particular tools, it actually takes some time. Clear, Lakshmi?
Yeah, it's clear. Actually, last week interview they asked these kind of things related to Kubernetes. Similarly, I applied for here. Even for Lambda also they asked
So
is
when
there
you're trying to
alternative for
compare the things, I mean, and just for suggestion only, you try to compare on the same things. You cannot just compare apple with banana. If at all you wanted to compare, you compare two apples, one, I mean, one from China, one from USA, like that. I mean, you have to compare with similar products. You cannot just compare Terraform with Ansible, Terraform with GitHub, and then you cannot find any differences. You have to find out. You have to find the differences only on the same products.
Okay, understood.
Okay, so the reason why I told is that, like, you told me like in generic, like what are the other tools which Terraform can be compared. So you should know like what are the other competitors to your Terraform. Okay, and what are the other tools which can give you the same benefits what Terraform is offering you at this moment. Okay, so just think of it. Okay, the reason why I told in the installation part before discussing this Terraform architecture, right? You'll understand like what is this core. So in this case, right, the Terraform core is the binary which we downloaded. This Terraform installation, everybody clear, right? Terraform installation, is it clear to everybody? Okay.
Yes.
Okay. This is for the Windows installations. Okay. I have also documented here for Linux installations. Okay. It is again very simple. Okay. Again, you have to go to the same particular path. Here, instead of Windows, select this Linux. Okay. Okay. Once you select Linux, you will have different flavors of Linux here, like CentOS, Red Hat. I mean, they both are from the same family. You can run the same commands. Like if you have a Ubuntu operating system, the Linux-based operating system, you have to click on this particular tab. Again, you have to go to this Terraform documentation. Okay, just click here Linux, and this is where, based on your operating system, if it is Ubuntu-based operating system, you simply have to copy these 3 commands. Okay, copy here. So eventually we'll copy all the commands, all 3 commands. And after that, you can just simply run Terraform-v. It is very simple. Terraform installation is very simple. Okay, if you are working on CentOS, just click on this particular tab, copy these 3 commands, and then and that's it. Terraform, you can run this Terraform-v. You'll be able to see that latest version already. And after that, okay, let us try to understand this architecture. Okay. So in this case, the Terraform core is the binary which we downloaded. And right, with core, we do nothing. So, right, we should know, right, on which cloud platform we are going to build the services. In this case, right, here we can have different cloud providers, be it your Amazon, be it your Azure, or any other like this. Okay. So here you'll have your cloud providers, and having your Terraform binary installed on your place. Okay, we have to write something called providers block. Okay, I will show you how to write providers block. Based on what provider block, right? If at all you wanted to provision AWS servers, so you have to have a provider block where your provider pointing to your AWS. Okay, then only, right, your Terraform will provision servers on AWS accounts. If your provider is pointing to your Azure, then you are going to provision like infra on Azure. And what we do, like, okay, this is your core, the Terraform binary. And this is where we'll be specifying it some provider block. And we use some kind of Terraform lifecycle commands. Okay, so Terraform code, we will be using some HashiCorp configuration language. It is like some kind of syntax we have to follow. And it is like, again, human readable syntax and all. Okay, just think of it. Okay, in this particular case, we have written some Terraform configuration code for like building any services. And we use some Terraform lifecycle commands. Okay, in the next slide, I will show you like the lifecycle commands. So whenever you run this lifecycle commands on this particular code, internally this particular code will get converted, in API commands. Okay, and these API calls will happen on your cloud accounts. So that means, right, we might have provisioned some code like to do like EC2 instance provision, and you apply this Terraform configuration code by running some lifecycle commands. So whenever you do like this particular code, because actually Terraform is written in Go language, and these instructions will get converted internally using some APIs, and those APIs will run, right, will takes place on your cloud. So that means based on what you have written in your configuration files, the respective services will get provision in your AWS accounts. And if you look at here, right, like here, we as a humans, we write these Terraform configuration files. As I said again, right, whenever you are writing Terraform configuration files, the configuration file extensions should be .tf files. Okay, this is a must. Terraform recognizes only the files which are extension with .tf. Okay, so we have to write, right, if at all we wanted to provision any services, we have to write some configuration files with extensions .tf. This will be applied, right, here. Like what this code does, like what is your Terraform binary does, which actually takes the input of these files, because we write these files and we apply these files. So that is where the required services will get provisioned. This Terraform core initially, right, if you have not provisioned any services, your Terraform code takes your Terraform configuration file as the input, and based on what instructions you have given, like maybe right, we run certain lifecycle commands, like let's say we have asked to create one EC2 server. Initially, it actually creates one EC2 server, and after completion of the server creation, it also creates one Terraform dot state file. Okay, it actually creates Terraform state file. The extension of this state file is .tf state. So what this tf state does, whatever servers it is provisioned here, this server entry will be placed inside this file. So that means the next time when you run again this lifecycle commands on the same configuration file, so that means this server earlier you have provisioned and it is already present in your AWS, and the entry of this server is already placed in your Terraform.state file. Hence, it won't build new server. It will see unless you make any changes. Okay, so only if you make new changes, your Terraform core, it actually compares. Okay, what is that ask is coming from these configuration files. While provisioning it, it also compares your state file, whether the required services are already created, and if they are made available in your Terraform state file, then it won't create the new infra. Right? If your entries, okay, so that means right here I have written some new configuration, maybe S3 bucket configuration. Since S3 bucket configuration is not finding in the Terraform state file, then it will go ahead and then create only that S3 bucket. Okay, that means your Terraform core always, whenever we run this Terraform lifecycle commands, it actually compares your like whatever configuration you write here. This is called as desired state. So that means what we wanted to achieve is the desired state. Your desired state will be compared with your actual state. So that means whatever infra you already provisioned, this infra related information will be stored onto your Terraform state file, and your Terraform core compares your desired configuration with the actual configuration. If they are already present, if your desired configuration is already present in your Terraform state file, then it won't create. Just think of it, okay, your desired configuration is not present in your Terraform state file, then your Terraform core, it will go ahead and then create the required services. Is it clear? But while we do hands-on and all, you'll understand even better. But at least, are you clear at this moment? Yeah, but when we do hands-on, you'll get to know even more like what we write here and what the information stores here, and how is your Terraform core is comparing this information with the state file, how the resources are getting provision, all those things you'll get to know when we do hands-on. Okay.
So whatever we write it in a .tf files will be core will take care of that and convert into TF state files.
It does not convert actually. So these files will remain there. Okay, these are the configuration files.
Yeah. Okay.
Which we create. Okay, based on what entry, like based on what configuration we have written. Like we might have written configuration for EC2, S3, or RDS, or anything.
Yeah.
Like the required services will provision in AWS. Like here, right? Whenever your EC2 server gets created, this EC2 server will have some IP addresses, right? Be it your private IP address, private public IP addresses.
Correct.
Right? This information will get stored in Terraform state file. Not that, okay, these files will be converted. These files will remain there. The information about
it's like
these services.
metadata.
It's like metadata. It is like the information about these servers, about these servers, be it any services, will be stored in your Terraform state file. And
this state file is readable by us, or it cannot be readable?
we can do some kind of manipulations on this Terraform state file. Yeah, we can read it. We can read it. It's not like encrypted. It's not like encrypted format. We can read it as well.
Okay.
We also have something called Terraform state file commands itself. So that means
Okay.
Terraform state
Editing
file
is
commands.
also possible.
Editing is also possible, but generally, right, people avoid making the state file changes.
Got you. Thank you.
Okay. Okay. Yeah. So this is the architecture which I was talking, and this is the installation part which we already completed. And this is like, these are like the steps. Like clearly I mentioned all the steps, like you have to go to this downloads folder, download that binary, keep that binary in whichever location. Suggesting thing is like you have to keep it in C drive, and then go to this advanced system settings, click on this environmental variables. So that is where you need to select this path variable and then edit, and then click that new. So that is where, right, you need to put the path of your Terraform binary location here. And after that, take the new command prompt, and you should be able to see what Terraform binary you have installed. Okay. So generally we write Terraform code in Visual Studio Code, because we can also write Terraform code in notepads. But if we are writing Terraform code, okay, in notepads, so right, and you do, I mean, your notepad will not highlight you any syntax issues and all, right? But take here, right? Let's say, right, I may write some kind of okay, let's say, right, resource and AWS underscore instance. Just some code, okay? I will teach you everything again. Okay. So let's say, right, if I write like this, normally this is how we write for provisioning an EC2 server. AMI equal to some AMI ID, instance underscore type equal to T2 dot micro. So normally, right, for provisioning an EC2 instance, okay, normally, see, we should know like what are the mandatory arguments. Again, I will just show you like what are the mandatory arguments. Like in order to provision an EC2 instance. So in this case, right, AWS underscore instance is the instance, okay. We need AMI ID and we need instance type. These two are the mandatory arguments in order to provision a server. Without selecting these two arguments, you cannot provision server, okay. You can also give a try here. Like while you are provisioning EC2 servers, like, right, the launch instance, when you go to launch instance, this is the mandatory step. The OS, like, right, in this case, right, if I choose this Ubuntu, the moment you choose this Ubuntu as the operating system which you wanted to load, it will give you the AMI ID. Okay, that means for this AMI is like Amazon mission image. For every image, Amazon provides an ID. Okay, in this case, right, the Ubuntu AMI ID is this one. And if I choose this Linux, and it will give me different AMI ID. So that means what I'm trying to say, like every image will have its own ID, and those AMI IDs are different from one to other. So that means every AMI ID will come up with its own AMI ID. Okay. So what I have to do, if at all I wanted to provision a server using Terraform, okay, this is the resource block. I will talk about this like everything. So here, AMI ID. So AMI ID means like, so in this case, the AMI ID of this Amazon Linux is this one. So I had to copy this one. Here, I had to put it here. and instance type. Okay, without specifying this instance type, again, if we just go down here, without selecting this option, we cannot build a server. We need to let Amazon know like what type of instance we wanted to provision. This is a mandatory step. So in this case, t2.micro is the default one. So what to do here, t2.micro. If I apply this configuration, a server will get provision with this AMI image and with this type of instance. Okay. So right, why I'm showing this here, right? Let's say right here, this is syntax which we have to follow. Let's say if I delete this codes here, and right, if I deleted this code here, which is starting here and which is ending here, it will give us some like syntax issues. The reason being is that because I have opened the code here and I did not close it here, right? So and because all these things, right? Just think of it. Okay, here in this case, only 3 lines of code, and we can easily identify any syntax issues and all. As we write your Terraform code, like more than 100 lines or maybe 500 lines, it is difficult for us to find all the syntax errors and then fixing your syntax issues. Hence, we recommend to write Terraform code in a Visual Studio Code. So what this Visual Studio Code is like, it is like code editor. Okay. So again, right, you can just simply go to Google and then Visual Studio Code download. Okay, Visual Studio Code download. So based on your operating system, you can download your Visual Studio Code. Okay, here in this case, if you're using Windows 10 and 11, okay, you can download this Visual Studio Code. It is just like again .exe file. You can just double click and then that's all. Next. This Visual Studio Code will get installed on your laptops. Once you install Visual Studio Code, right, you can just open your Visual Studio Code. So right, going forward, instead of we are using Notepad for writing Terraform code, we write Terraform code in the Visual Studio Code. Okay, so once you open your Visual Studio Code, it looks like this, and go to extensions. Okay, click extensions. Just search with HashiCorp. Okay, this one. Just install this plugin. So here you'll have something enable or here, like in this case, right? If you look at here, this particular plugin, HashiCorp HCL, it is not installed on this Visual Studio Code. Hence, it is showing like install option here. Here it is already installed. Hence, it is not showing here. But in your case, once you downloaded this Visual Studio Code, you go here, this extensions place, and then install. So once you install, this HashiCorp plugin will be installed on your code, and then go here. Okay, so you can like let me create a folder, my desktop. Terraform training. Okay, I just created a folder. So I wanted to open this folder from Visual Studio Code. So what I'll do, I'll go to this like open folder. Select the folder which you created. KodeCraft Terraform training. Okay, since this is just a empty folder, I just created a folder and nothing else I created inside. Okay, and this is the folder which I created on my desktop, and I opened that folder in the Visual Studio Code. Here, right, we can write this Terraform configuration code from the Visual Studio Code itself. Now here, if you put here new file, so that means we can create files here. Okay, so this will be the name of my file. As I said, all the Terraform configuration files, the extension should be .tf. So that means here I'm going to create a file, main.tf file inside this directory. Okay, so see, right, since you have installed this HashiCorp extension, the moment you put this .tf as the extension, like your Visual Studio Code identifies this is a Terraform configuration file, and this symbol will be appearing here. So here main.tf file. So that means this is the file which I am created. Now if you wanted to go and check here, when you refresh here, you can check right main.tf, and the type of file is tf file. So when you say here tf file, this is a Terraform configuration file, and this is where we will be writing the code, like whatever code which earlier I was writing the code in Notepad. The same code, if you write it here, if there are any syntax issues, it will just highlight immediately, okay, where you are making the syntactical issues and all. But in case of Notepad, the Notepad will not highlight you the syntax issues and all. Now let me go back again here. Okay, so everybody must install this Visual Studio Code, and then again here I have provided, like you should go to here extensions. This is where you select this HashiCorp Terraform and then click on install. This plugin will get installed, and so here I will write Terraform configuration file to provision an EC2 server on my AWS account. So that means from my laptop to AWS account, there should be a connection. Authentication has to be taken place. So for that, what we have to do, right? We will install this AWS CLI. As I told you last week, right? Everybody must install AWS CLI. Okay, right? Again, if some of you who did not install AWS CLI, you have to install. Otherwise, right, you cannot practice. AWS CLI you have to install, and then you need to configure your AWS CLI. Okay, and this is the place, right? When you go to this link, so this is where you can see the links like this: AWS CLI. This is MSI installer. Just download, double click, next. Your AWS CLI will get installed, and after that you need to configure your AWS CLI. So in order to configure, you need to run this AWS configure command. Let me show you whether I have documented. Okay, it is not documented. So once you downloaded and then installed, so when you run this AWS, it has to give you like this output. That means you have installed AWS CLI onto your Windows laptop. So that is where you need to configure AWS CLI. So in order to configure AWS CLI, you need to run a command called AWS space configure. I mean I did cover right this one last week. Did I cover or I didn't cover? How many of you do not know how to configure AWS CLI?
I have done the configuration.
Yeah, I have done the configuration.
I mean, I did cover right this one how to because I have created some. I mean, with the help of AWS CLI commands only.
Yeah,
Like
it is
we
been
have
covered.
we have created some services. Okay.
Correct. S3
Okay.
services you have shown in the line.
Yeah, correct. I mean, I created S3 buckets using AWS CLI commands, like using like AWS S3 and then make bucket and then the bucket URL, which is what I given. In order to run that command, you need to install AWS CLI and then configuring it. So when you configuring it AWS CLI, you have to provide kind of right. So if you go to command prompt, AWS. So once you install AWS, you can also run this command AWS -version, which will give you like that AWS CLI version you have installed, or you can just simply run AWS, which will show you like your AWS is already installed. And after that, you run this command AWS configure. So when you run your AWS configure, so this is where you have to pass your access keys. So how will you get access keys? Anybody wanted to say like how will you generate this access key and then secret key?
Yeah, whenever we create IAM user, we have an option over there.
Correct. So right. So when I mean we have to have an account like a user account in your AWS accounts. Okay, so whenever we create IAM user ID, right? Let me show you again for some of you benefit. So when you go to IAM, so under users, okay, either you can create new user and then can generate secret key and then access keys, or you can select the existing user which is already created. You can go to the security credentials, right here, create access key, right? You can select this one and then understand. Okay, never ever share these access keys and secret keys to anybody, and do not store this access key and then secret key in your GitHub. Okay, because the moment you expose these keys, right? Expose is nothing but you are just sharing these keys to any other third party, right? They can use, right? They can use these keys and then they can create, like it is as good as you are sharing your AWS account credentials. That means they can spin up a number of resources and eventually like bill will occur on your AWS account. So this is how, right, you can create your access key and then secret key. So once you create, right, once you generate this access key and then secret key, you go to your command prompt, run AWS configure, right? This is where you need to copy, right, this access key, and the next option it will give you like AWS secret key, and you can have any one of the region as your default. So in this case, my default region is AP-Southeast-A, which is Singapore region, and default format can be anything, just simple. Okay, from now on, if this access key and secret access is valid, and if they are having permissions, it will give you like AWS S3L. I mean, from now on, we can run this AWS CLI commands. So if I run here AWS S3 and then ls, it will just list me the bucket which is exist in this region. Okay. The reason being why we need to do this one. So the moment you do this AWS configure, right, and providing this access key and then secret keys, those will get stored program files, Amazon, not here. So here, so inside your users, okay, here .aws, the folder will get created, and whatever credentials like the access key and then secret key, those will get with credentials file, right? See, so that means whatever access key and then secret key you have passed your command prompt, they will get stored in this file. Okay, and when you're trying to write these Terraform configuration files, and right, because we run some kind of lifecycle commands, Terraform lifecycle commands, how will your Terraform, I mean, how will your these files will get executed on your AWS account means during your runtime, this Terraform, right, these configuration files will take this file as the authentication. Okay, if these values are valid, then they will use these files for your authentication of your AWS account. Clear? So this is why I asked everybody to do this AWS CLI installation and also configuration. Is this clear now?
Sir, MFA is mandatory, sir.
MFA is not mandatory.
Okay.
MFA is not mandatory.
Okay, sir.
MFA is like additional security for your AWS account. If you wanted to have one more layer of secret, like one more layer of authentication. Okay, in addition to your password, you also need to have your MFA as the another layer of protection, actually, like kind of security.
Yes.
Okay.
Okay, sir.
And okay, let me spend another 5 minutes. I'll just walk you through like Terraform documentation. Probably, right, we can spin up servers in tomorrow's class. Okay. And this is the official document, right? So as of now, we have installed this Visual Studio Code and we have created this main.tf file. But just think of it, okay, we do not know what to write here, right? As of now, we do not know what to write here. So based on what you write, the respective services will get provision. Okay, let us try to understand what need to feed to this particular file. Okay, right? The first thing first, like we have to define a provider section. Okay, so provider section is the where we will be specifying like these providers. Okay, so provider section is the mandatory one. So without we specifying this provider section, and Terraform does not know in which cloud provider you wanted to provision. Okay, just click here terraform.io, go to this registry. Okay, here click on browse providers. So these are the supported providers by your Terraform. If we come down and then see here, see Terraform is being supported almost 4,200 odd providers. So that means these are the different types of providers. Ravi, you asked me, right, like whether with the help of Terraform we can do this Docker Kubernetes and all, right? You can have your Docker Kubernetes somewhere here. Okay,
Yeah, Kubernetes has the top, yeah.
Yeah, Kubernetes is here, and similarly Docker also you'll have here somewhere. Like you can also write because here we have 4,000 entries. It is difficult to navigate each and every page whether to find that, and you can simply go to Google Terraform provider Docker. It will directly take you to this page. Okay.
Okay.
This is, I mean, right here we have 4,000 entries. It is difficult to navigate each and every page.
Yeah, very.
Okay, and right now this is the Docker provider, and okay, now initially, right, when you go to this terraform.io, so that is where you will see that registry. Let me again show you. This is important. Terraform.io. Go to this registry, right? For now, let us just look at this provider section, browse providers, because we have to define provider section. Okay, so here our interest is to spin up servers on AWS account. So we have to select this AWS. Okay, and you can check, right? Downloads this week, right? Like downloads this month and downloads this year. Like how many number of times this particular provider is downloaded? It's almost like 634 million times. That means there are many people all over world, right, have downloaded this particular provider to spin up their AWS services and all. Okay, so then how do we use, like here, right? When you click here, so this is where he will give you, like this is the provider section, like this whole thing. But this is actually a required provider. So in this case, like HashiCorp AWS. Okay, and this is the version 5.56.1. So these are like previous versions. So always it will give us the latest version here, 5.56.1. And if you wanted the previous version, you can just, this is just like provider version. Okay. Now what we have to do, and this is the provider block. So whatever provider name you give here, so in this case, they have given this syntax, provider, and then provider name. So since this is a HashiCorp configuration language, we have to follow the same syntax. Okay, it starts with curly braces and ends with curly braces. Inside this, it actually supports few arguments. Okay, again, I will show you what are the arguments supported by this provider block and all. For now, right, I will just copy everything. Let me go to this Visual Studio Code and then put it here. Okay, here the provider is AWS. Like here, there are few arguments which will support by this provider block. Like if I go up little, and if you go to documentation here, see if you look at here, right, the provider block AWS, and the region. Because once we get into our AWS account, we have to specify in which region, right? Based on what region you select, you are going to provision services on the same account, I mean, on the same region. Similarly, here also, this is the mandatory argument. Okay, this is the mandatory argument. Region equal to US-East-1 means this is like North Virginia region. Based on in which region we wanted to create resources, you can have that region code. Again, how to get the region code? You can go to your AWS account here. So if I wanted to spin up servers in Singapore region, this is where I need to choose the region code AP-Southeast-1. Okay, now let me copy this one. Right, you can just put it here. Okay, and region code you can change it. AP-Southeast-1. Okay, so with this we are done with the declaration of this provider block. Okay, provider block, and this is like Terraform provider version. Now after that, going forward, like whatever resources we create in AWS, everything we have to define under resource block. Okay, similarly here we have provider block, right? Similarly we have to create resource block. Okay, and how do we create resource blocks and all? Probably I will take tomorrow, right? Okay, so based on what resources, like here in this case, right? Let me just quickly walk through here. So if you wanted to provision any EC2 instance, so under the same page, you can see, right? Under AWS provider, these are the supported resources, right? By AWS, by the HashiCorp. So what is our interest is like we wanted to provision an EC2 server. So, right, if we just scroll down all the way, little down, this is where you can see like Elastic Compute Cloud, EC2. Just expand this one, and everything in AWS we treat as a resources. Let's say if you wanted to build an AMI image, okay, this is the resource type. Okay, like here, this is the resource type. Let's say, right, the same way, like whatever you can do it in console, everything can be done using Terraform. If we calm down, little down, so this is where like we cannot remember, right, everything. So we have to refer the Terraform documentation. If we wanted to provision an EC2 instance, so like this is the resource type, AWS_instance. If you wanted to know more about this particular thing, you have to read this documentation. So this is the resource block which I was talking. It has to be started with the resource and then resource name. Okay, in this case, resource name or resource type. Okay, AWS_instance, AWS_instance. Here, this name can be anything. You can give any name, it accepts. But I will let you know later on the importance of this name. Okay, all those things. But for now, you can give any name here. And then AMI. Again, as I said earlier, this AMI values will vary from OS to OS. You have to get this AMI ID by logging into your AWS account. And then what type of instances? And then the tags for this, like tags for your EC2 instance. Okay, you simply have to copy everything, this block, go to your Visual Studio, copy here. Okay, here under AMI section, just erase this one, go to your AWS account, select EC2. So because now I wanted to get the AMI ID, which will be used for provisioning server. So to get the AMI ID, just click here, launch instance. So this is where I will just choose this Ubuntu. So this is the AMI ID. So right, it has to be start with quotes and it has to end with quotes. Okay, if you are missing it, then it will give you some syntax killer. Instance type. Okay, based on what type of instance you are going to provision, you have to specify here. Okay, now I have written Terraform code. Like you have to have this provider block, that is mandatory. And after that, what resources you wanted to provision. Based on that, you have to construct your resource blocks. So in this case, I'm going to provision one EC2 instance. So for that, I have to write this kind of resource block, resource, and then resource type. So in this case, AWS underscore instance. This name can be anything. And it actually, this we call it as arguments. Okay, this particular resource accepts few arguments. I will walk you through all the steps, like what are the supported arguments, for which right here you can look it out under the same instance, argument reference. Like these are the arguments supported by this resource. Like in this again, what are the mandatory arguments? What are the optional arguments? Everything I will cover you through. But before I provision, I need to run some lifecycle commands as well. I intended to cover everything today, but for some reason, yeah, I couldn't because I went into a bit slow. That is fine. But yeah, I will we will cover everything from tomorrow wherever we left today.